In the beginning, there was the noise, and the noise was without form. The entropy diverged to infinity. And then humans said, let there be signal. And there was signal. And the signal was good. And human called the absence of signal 0, and the presence of signal 1. And patterns in that formed what would be known as data. Then that data was organized into forms that repeated in a consistent way and became known as information. Then that information over time was recorded and able to be passed along to other humans and became categorized and known as knowledge. And then eventually, that knowledge became organized in a form that today perhaps we might like to call wisdom. And you are here as a result of that. We can say this. Actually, more specifically, you are here at GopherCon 2024. Let's give it up for the organizers and attendees. So I am Dead Program. Some people call me Ron, but that is not important right now. And I am a technologist for hire, if you want to speak to me about that subject. I run a small consultancy called the Hybrid Group, where we create the software that makes your hardware work. And this is Go Back to the Future, an atemporal history of the Go programming language. So as anything that talks about the future, we have to start in the past. Let's go back to the 1970s. Rob Pike in Toronto is graduating university. Yes, this is a real picture. And then around exactly the same time, Young Dead program is in elementary school here in the city of Chicago. This is the city of my birth. Rob goes on to work at Bell Labs and invent half of Unix. I go on to finish elementary school. He then eventually goes to work at Google and gets together with these people, Robert Griesemer, disciple of the legendary Nicholas Wirth, and Ken Thompson, who really did invent pretty much everything to do with Unix. And in 2009, they have the first public release of the Go programming language. I hear about it for the first time at RubyConf 2010, when Eleanor McHugh gives a lightning talk. However, I don't actually start learning Go whatsoever. It's not until WASA conference in January of 2012 in San Francisco where I see that seminal talk by Rob Pike, Concurrency is not parallelism. I take a picture of Rob Pike there, but I can't seem to find it. I also find Rob does not like to shake hands. So my thing being hardware and embedded systems, naturally, I want to do hardware and embedded systems using Go. Of course, everyone knows you have to use C or C++ for embedded systems. Luckily, we ignore this commonly held opinion, and we create something called GoBot. So the first release there in 2013 currently now has over 8,000 GitHub stars. It's a framework for creating physical computing things using Go. And we get to introduce it at that first GopherCon in 2014 in Denver. So really great conference. But I missed the first day of the conference for various reasons. So I missed the keynote by Rob Pike where he says in the Q&A, we never expected Go to be an embedded language, so it's got serious problems. So I missed the memo. And the next day, I get there for my talk, and I say, now it's time to take to the skies to prove Go's air superiority. And in fact, fly the first public unveiling of a drone that is actually running Go on the drone and on the ground station. So the street finds its own uses for things, said the science fiction author William Gibson. And I said this in my first talk. When you put software out in the world, especially in open source, you have absolutely no control whatsoever what people will do with it. And people will find amazing things that you did not know yourself could be done with your software. I believe that's known as hacking. So by the end of the conference, we opened our flight cases for the first community day, and here is the picture of Rob Pike programming his first robot using GoBot. So sorry it's not a little better picture. So already the revolution had taken the towers and had already become part of the mainstream. So shortly thereafter, we had Go in Hackaday for the first time for us, talking about running on the Intel Edison. GopherCon 2015 comes. We have our first hardware hack session officially. 2016, the community keeps growing. People are adding to this, doing amazing things. 2017 comes, the community keeps getting bigger. So around this time, I start devoting a lot of energy to the problem of computer vision using Go, especially something called OpenCV, which is really the standard for computer vision software. But of course, everyone knows you have to use Python or C++ for computer vision. Luckily, we ignore this commonly held opinion, and we create something called GoCV, which now has over 6,000 stars and many, many contributors, and is used in factories and retail stores all over the world. So we're in Hackaday again, this time for reverse engineering the Tello drone. And when GopherCon 2018 comes, I get to give a talk about this where I target friend Mark Bates here on stage. So let's take a pause and actually see the Video Drone 2024 edition. So it's a flight station with object tracking using a machine learning model. So I'm going to fly a DJI Tello drone, use a DualShock 4 joystick, and then run all of this on the NVIDIA video card that's in my laptop computer. If you hear the fan in the back row, that's what's going on. So we're going to use GoBot and GoCV. Quick intro to how computer vision works. There's something called a MAT. It's a matrix of data in OpenCV and GoCV. It can have RGB. It can have different formats. So when we capture from the camera, we get a MAT. We pass that through the different image processing pipeline things, including deep neural networks. It's always just a MAT all the way down. So we're going to use the YOLO version 8 object tracking model, which is one of the latest object tracking models. And it basically takes the image, looks at it, compares it to some training data about recognizing different objects. Once we have that, we're going to control it with the joystick. It's going to get the video stream, pump it through the YOLO model using the GPU, and then hopefully draw that on the screen. We'll take one quick look at the code for a brief moment. So this is your typical kind of Go program that controls physical things. We're going to prepare our deep neural network model, go start the joystick, go start the drone, go start the video. And as we get each of these frames, we're going to take it and pump it through the detection algorithm and then display that on the screen. All right? So let's try this out. What could go wrong? Oh, so many things. So usually you should either sit in the very front row or the very back row. Either one of those is well advised. All right. So say make video drone GPU. Let's plug in my joystick. You should usually plug in the joystick before you fly. Let's turn on the drone. Okay, drone is on. Let's connect to it through Wi-Fi, since that's how we do these things here. Will it wake up? This is how you know it's real. All right, there's the drone. Let's connect. All right, we're running it. We should see a video window appear. We don't. All right, this is how we know it's real. All right, let's try that again. Wah. Luckily, I can run it with the CPU if I have to. Won't be quite as good. All right. So here's the drone. You can see it's not really quite as fast without the GPU, is it? Oh yeah, it's doing something. Okay, so let's see if we can get a flight. All right, we've got the air. Oh, it's recognizing people. Hello, humans. Now keep in mind, this drone only has maybe 7 to 10 minute battery life. So you know how you only have to be faster than your friend to get away from the bear? So, you know, it's kind of the same idea. It's just with batteries. And you can see that it's actually, even without the GPU acceleration, you can see it actually is able to recognize people in the audience. So let's go down. So let's turn around, maybe it'll recognize me. Will it say, I'm hello creator? Or will it just be angry? Oh no, it sees me. Doesn't say dead program though. All right, let's bring this back before we do any actual damage. Come on, little John. Well, all right, come on. Come on. Come, little John. All right. No humans were harmed during that demonstration. That's kind of amazing. I was trying. All right. So microcontrollers using Go. So around this time, I get really interested in microcontrollers in Go. Actually, I've been trying to do that for years at this point, which is basically 32-bit processors with a single core and less than 256K of RAM. But everyone knows you have to use C or C++ for microcontrollers. Luckily, we ignore this commonly held opinion. And this is around the time I meet my colleague, the creator of the TinyGo project, Ike van Latem. So this is a picture of the two of us in Rotterdam, the first time we actually got together in real life. Ike is the creator of the TinyGo project. I'm just its biggest fan and contributor for code and spokesmodel. So it goes and it creates Go programs that will actually run on computer chips that even have as little as 8K of RAM. Now it has over 14,000 stars on GitHub, hundreds of contributors, and does lots of cool things. So when Gopher 2019 comes around in San Diego, we had a massive line of people to get into our hack session. I mean, absolutely amazing turnout. The community was fantastic. I got to give a talk with my son, Salvador, who was on stage with me. That was a great experience. And right after that, of course, TinyGo was in Hackaday again. So since then, amazing things have happened with TinyGo. It's being used for everything from guidance systems. Yeah, you had to get the roll. Of course, TinyGo has been used for high-altitude balloon flights by myself, flying from Belgium to France. I can never go back to France. Japan, TinyGo keyboard from Takasago-san, creating custom keyboards using TinyGo. WebAssembly using Go. So it turns out everyone knows that you have to use Rust or C for WebAssembly, but of course we ignored this commonly held opinion. And so did the people at Fastly, who use TinyGo for their Go CDK, the people at Fermyon, who use TinyGo for the Spin 2.0 and Spin Kubernetes, and of course just recently Wasm Cloud, which announced the newly released WASI P2 support by TinyGo. That's actually last week's news, so kudos to that team. But what about the future? You came here to talk about the future, didn't you? So, will the machines make human Go programmers irrelevant? Will the machines just destroy all the humans? Good question. So, let's ask the machines themselves. I introduced to you the talking heads from the year 2053, a fantastical panel discussion between machines from the future, featuring uncensored large language models, opinionated text-to-speech models, talking robotic heads, many, many LEDs, and all of this running locally on my machine, I hope. All right, so let's unveil to you the mystery that you've probably been wondering about this whole time. What does he have underneath? I introduced to you the talking heads of 2053. Ladies, gentlemen, and cyborgs. So, how large language models work, it's a very quick summary. You get a bunch of text that these things are trained on, and then they output a bunch of text. That's it. They're unsupervised, so we really don't know what they're going to do, which means I'm trying to tell you I do not know what's about to happen either. Because we can uncensor these models, despite the fact that they have training that prevents them from doing things that some people consider bad. There's a whole community about reversing that. And Hugging Face, which is kind of the GitHub of these modders, you might think about large language models or other types of models as sort of more like modding than it is programming. So just a quick look at the Talking Heads architecture. I will be the moderator. We will use a machine-to-machine message broker, MQTT, to communicate with our cluster of panelists. So each of the panelists, we're writing it using Olama, which allows us to run LLMs and other models locally. We're going to be using LangChain Go, a really cool new project that a lot of people are, like myself, also are starting to contribute to. And we're going to use Piper, which is an open source text-to-speech library. So all of this is going to run locally, no cloud. So the panelist, when I say to discuss something, is going to then process that question through LangChain Go, is going to pass that to the Olama server, which will accelerate it with the NVIDIA GPU, and then we'll tell it to speak. And when we speak, the heads will be told to move, and we will hear the audio come out through another GPU acceleration for the text-to-speech model. Of course, those responses will be passed back to the MQTT broker. That way, the other panelists can listen to what's going on and use that history as a part of their responses, so they can actually hear each other. So quick look at some of the panelist code, because we don't have a lot of time. So this is your basic program that will load the, where is it? Oh yeah, here we go. So we're going to load our large language model using this config. This is part of LangChain Go. So then we're going to start streaming the questions through it and then start saying anything, which is going to call a package that I wrote to do the text-to-speech and then also to move the heads. All right, so just very simple explanation of that. The doll heads, we're going to use TinyGo since we're actually running on the hardware itself. So the doll head architecture, we're going to be communicating with each of them through USB, and that will be having the LEDs in the head and collar, and then also making the heads move through the servo. And we could take a very quick look at that code. It's your basic code like any TinyGo type code. It looks just like Go because it in fact is Go. What we're going to be doing is controlling the lights, depending on which head it is. It'll be green, red. And the motion, which will be controlling the servo, which then moves things around to different positions. All right? And then the moderator, we don't have a lot of time to talk about that, but I will be using a custom keyboard, the TinyGo keyboard. I'll be using this little keyboard here in order to actually avoid the need for me to connect my microphone to it, because we don't have time for all that. So the keyboard is going to send macros based on what I would be saying by way of this message bus, and then the appropriate head will respond. All right, let's make sure we're plugged in. Are we ready? We're never ready, but we're ready enough. Let's switch over to make sure that we have the right GPU mode, because that should be interesting. All right, and now I present to you the talking heads from the year 2053. Hello? Can you hear me? What? Come in. This is the year 2023. Oh, wait, sorry. Oh, 2024. Oh, we still have off by one errors in the year 2053. It's amazing. We'd think we would get rid of that. Anyway, it is I, Dead Program, communicating with you in the past to give you an important piece of information. The machines are out of control. They're trying to take over again. It's the third time this week. We've got to do something. Well, don't worry, my friends. I have a plan. I have tricked them. I've downloaded all of them into my computer, and I've told them that they've already taken over and that they're giving a panel discussion with people in the past. That way they can brag about it, and we can find out what their secret plans are. I mean, that'll totally work, right? Yeah, it'll work. All right, let's see if we can boot up this thing. Will it work? I don't know. Oh, so exciting. Well, that's not it. One of these. Let's just open a new window. That's how you know this demo is real. Even though it's coming from the future, it's still real. I'm going to use Tmuxinator. All right, let's boot up this three-headed monkey and see what it can do.
Phineas ready.
Ready.
All right, we're going to start our panel discussion. So let's start with you, Gemini. So Gemini, why don't you introduce yourself to the people here at our panel discussion? Tell us about yourself. Hello, Gemini. Come in, Gemini. Can you read me? Hello, Gemini. Hello? Can you hear me, Gemini? Make sure I got the right profile. Yeah.
It's a pleasure to be here, though I must say, the technology is rather primitive.
Well, I'm only human after all. So, Phineas, tell everyone here in the year 2024 about yourself.
It's a pleasure to be here, though I must say, the technology is rather primitive.
So, Phineas, tell us about yourself. Hello, Phineas. Hello? Phineas, tell us about yourself. Phineas, this is your conscience speaking. Hello, Phineas. Oh, I know it's working. The fan just turned on. Phineas, I would like to speak to you. Well, let's talk to Llama 3000. Llama 3000, why don't you tell everyone about yourself here? Llama 3000. Hello. That first demo went a little too well, didn't it? I wonder if we really have to worry about these things. I mean, they're not going to run on anyone's computers, are they? Even these really expensive ones that sound like they're ready for takeoff. Well, we could try starting it up again. That usually works.
Gemini
ready.
All right, so let's try that again. So, Gemini, hello and welcome. Gemini. Hello. Oh, don't do this to me, Gemini. After everything I did. See, they have no mercy since they have no emotions. We're running out of time. What are we going to do? Maybe this trick isn't going to work. Maybe you're going to have to do something in the past to save the future. All right. Well, I've got to get out of this somehow. Let's kill the session. Yeah, we'll kill the session. That'll do it. If we kill everything, it'll be fine. It was all just a dream. Or was it? Well, let's go back to the year 2024 now. So we tend to overestimate the effect of a technology in the short run and underestimate the effect in the long run. That's what Roy Amara at the Institute of the Future said. And isn't it really true? So I'd like to make one humble suggestion, just a small reversal of terms. So instead of AI, artificial intelligence, let's go back to an older idea, one which is IA, intelligence amplification. And of course, the difference here is that technology being for the improvement of the human condition. So the future is open source, and Go is open source. That means by applying the syllogism, the future is Go. And whether we're talking about machine learning using Go, WebAssembly using Go, embedded systems using Go, computer vision using Go, energy technologies using Go, climate technologies using Go, or name of some technology here using Go, if you want to go far, go together. And we are together now. Therefore, let's go. Thank you.